Welcome back. In the last session, we covered the student workbook problems level 1. Now we'll continue level 2. Okay. Write down problem number 1. For small signal AC operation, a practical forward biased diode can be modeled as. Okay. Option A, resistance and a capacitance. Option B, ideal diode and resistance in parallel. Option C, resistance and ideal diode in series. And option D, resistance. See, if you take a PN junction diode, this is what? If you take a PN junction diode, right? I told you, right? If you take third approximation, then we can model it like this is what is our RF, the forward resistance, and this is what is our V gamma. That is what we are modeling, right? That is what your third approximation. It is close to your exact model because I told that if you account the dynamic resistance. What is dynamic resistance? Your dynamic resistance. This is what is our RF. Then RF is nothing but dV by di. Then we got eta Vt divided by I. Right? Therefore, now this is what is calculated from exact model equation where I is equal to I naught into e to the power v by eta Vt minus 1. Even if this is third approximation model, if you take RF constant, then it is third approximation. But if you take this RF with respect to your bias current, which is from accurate model, then this approximation model is almost matching to what? Almost matching to your exact model. But remember, this is what is for DC operation. If you take DC operation for DC voltage or DC signal excitations, this is what is represented. But if you ask me your AC signal or AC operation, whatever DC voltage you have, right? What is your resistance of your V gamma battery? What is the change in the voltage? 0. Then what is this? It is only left with your RF. Remember, it is only left with your RF. That RF is nothing but eta Vt divided by I. This is what is very important. If you take DC operation, it will have on resistance and then V gamma drop. That is what is represented. But in AC, we will not bother about DC quantities. We bother about only AC quantities, right? Therefore, whatever, when you apply a voltage across this, let us say this is what is voltage across it. If you observe clearly, I can explain in a different way. When I say this is what is our voltage, this is what is your voltage, whatever you have. Therefore, this is nothing but your VDC plus VAC, whatever you have, right? Then the same voltage is there across it. When you increase this voltage, out of V gamma is dropped. That is what is dropped, and the remaining voltage is going to RF. Therefore, voltage across RF is increasing. Therefore, your current is also increasing. Therefore, overall, when you increase the voltage V, the current which is what is flowing through it, this is nothing but your I. That is also increasing. That is also increasing. But if you take AC resistance, that is nothing but what? Delta V divided by delta I. What is change in I? Because of change in V. When you have change in V, V2 minus V1, whatever V gamma you have, that will be cancelled it out. Only the drop in the resistor, the change in the resistance voltage will give you the change in the current. That is what it is. Okay. I think already we saw or we had seen all these things, dynamic resistance versus static resistance. For DC operation, we have to take V gamma and then dynamic resistance. That the dynamic resistance is calculated from your AC equations. Okay, this is what. Therefore, what is the answer? The answer is nothing but D. It will be taken as a resistance. Okay, answer is D. Now, problem number 2. The GNR diode in the circuit shown in figure has a knee current of 5 milliampere. Number 2. GNR diode in the circuit shown. Knee current. What is knee current? IZ minimum. IZ minimum is equal to 5 milliampere. and maximum allowed power dissipation PZ maximum is equal to 300 milliwatt. Minimum and maximum load currents that can be drawn safely from the circuit keeping output voltage constant. Therefore asking for the minimum current and maximum current IL max for the circuit. The circuit is this is what is our load. This is 9 volt battery. This is 50 ohm. This is 6 volt. And this is what is our output voltage. And we know that this is what is this, right? I think again it is similar procedure whatever we had seen before. Now this is nothing but your source current IS, and this is nothing but your GNR current IZ, and this is what your load current IL. And what is your V0? V0 is nothing but your GNR voltage, which is nothing but 6 volt. Right? Therefore tell me what is your, we know the equation. What is the equation? We know that what is your IS? IS is nothing but IZ plus IL, IZ plus IL, equation 1. And what is your IS? IS is nothing but 9 minus or VS, VI minus V0 divided by RS. That is what is your IS. Therefore, what is your IS? Therefore, if you substitute, what is your IS? IS is nothing but VI, 9 minus V0, 6 divided by 50, which is nothing but 3 divided by 50. What is 3 divided by 50? 60 milliampere. Therefore, your IS is nothing but 60 milliampere. This is what you can call it as equation 2. The source current is 60 milliampere. We found our thing. Now, what do you want to find? We want to find IL minimum and IL maximum. Therefore, what is IL? 1 implies, what is your IL? Your IL is nothing but IS minus IZ. Right? Therefore, what is IL minimum? IL or IL minimum is equal to, your IS is constant, this is minimum only when IZ is maximum. When IZ is maximum. Therefore, what is IS? We already calculated. That is nothing but 60 milliampere minus IZ maximum. How will you calculate IZ maximum? IZ maximum is nothing but 60 milli divided by PZ maximum, which is VZ into IZ, divided by the VZ. Right? Therefore, 60 milli, what is PZ maximum? That is given 300 milliwatt. And what is your VZ? 6, which is 50 milli. Therefore, you will get 10 milliampere. Therefore, what is your IL minimum? IL minimum is 10 milliampere. Similarly, what is your IL maximum? This is IL minimum. Similarly, what is your IL maximum? Your IL maximum is equal to IS minus, then this is what is minimum? IZ minimum. What is IS? 60 milli. What is IZ minimum? Which is given 5 milli. Therefore, what is this? This is 55 milliampere. Therefore, the minimum current you can draw from the circuit is 10 milliampere. The maximum current what you can draw from the circuit, GNR circuit, is 55 milliampere. Therefore, what is the answer? The answer is C, 10 milli and then 55 milli. Answer is C. Okay, take it. Then we will solve problem number 3. Just for your understanding, here when you say VI, this is DC, VI, DC. But here it will be delta V, delta I. That is what is the representation. Okay? Because whatever DC you have, that will be taken out. because delta V gamma is 0. There is no change in V gamma. Whatever change in current you are getting, that is because of change in voltage across your AC resistance. That's why under AC condition, your diode can be represented as dynamic resistance. But under DC condition, you can represent like V gamma along with on resistance. Okay, that on resistance can be fixed. Then that is third approximation. If that on resistance is derived from dynamic resistance, then it is almost equal to your exact model to that bias point. I'll give you one more minute. After that, we'll see problem number 3. The circuit shown in figure is best described as option A bridge rectifier, option B ring modulator, option C frequency discriminator, option D voltage doubler. First of all, let's see what is this. This is a sine wave and this is a PN junction diode and a capacitor. If there is a PN junction diode and a capacitor, clamper. Clamper means not completely clamper, it's not typical clamper where the voltages will be different. Okay, and this is what is our output. This is output. Okay, let me call this as diode D1, diode D2, capacitor C1, capacitor C2. Right? Now, what do you get? Now here, let us say sine wave is applied, whatever may be, I told you. Now, if it is a clamper, I told, apply the input for which diode is on. Whether it is positive or negative, one of the diodes will be on. Therefore, you can conduct anything, right? Then you can start with positive cycle. Maybe only for this case, I will try to explain with respect to sine wave, which is what is given, not like transfer function. Maybe what I will do, I will call this as V1. This is what is V1, and let me call this as V2. Therefore, what is your output voltage? V1 minus V2 or V2 minus V1, anything is fine. Here sign is not important. The drop across V1 and V2, that is what is important. Okay. Therefore now, for the positive cycle, let us say I want to take V2 minus V1. Okay. Now, if that is what is the case, now tell me. Now, case 1, this is what your Vi. Okay, it's a sine wave. Let us say Vi is greater than 0. When Vi is greater than 0, right? Then what will be the case? When Vi is greater than 0, initially this is off, this will be on, then your capacitor will be, therefore your D1 is off and your D2 is on. Then what is your circuit? This is simply this, right? Let us say this is your Vi, then this is what is your capacitor C2. Then what is your V2? Therefore, this is what is your voltage across the capacitor only V2. Therefore, what is your V2? V2 is equal to Vi. It is following this. Your capacitor will charge as it is. Okay. If I neglect the on resistance or ideal diode, then the voltage will be charged across your capacitor. Right? Provided the voltage drop across your diode is greater than 0. Therefore, this is what your Vi and this is what is V2. Vi minus V2 should be greater than 0. Okay, that's fine. Similarly, when Vi is less than 0, case 2, when Vi less than 0, negative, this will be on because we don't know what is this voltage initial time at a time t is equal to 0. That is what I am saying. At a time t is equal to 0, at a time t is equal to 0. Initial time, voltage across the capacitor is 0. Then your diode D1 will be on, and D2 is off. Then if you take in that way, then this is what your C1, therefore this is what your V1. See, V2 is equal to Vi, therefore your V2 is equal to Vi in that time. Then in this time, maybe initial time, then whatever, because this is off, you can say V1 is equal to 0 initially. at a time t is equal to 0. Initial condition is 0. Then here V1, what is your V1? Your V1 is equal to Vi. Therefore V1 is equal to Vi, and maybe initial time if you start, whether you can start with positive cycle or negative cycle, that's what I'm saying. If you start with that, then your V2 will be 0 at a time t is equal to 0. See, these two are possible solutions. If you start with this, then your V2 is equal to Vi and then V1 is 0. If you start with negative cycle at time t is equal to 0, that's what I'm saying. Then your V1 is equal to Vi and then V2 is equal to 0. That's why we don't know what to be start, but which is on, which is off. But now let's respond to actual sine wave, then we'll see. You'll understand the problem. Okay. This is what is important. When I say this is what your sine wave. Okay. Now 0. Now we don't know what is this voltage, right? Nothing is given. We don't know. It could be anything. Now if you observe clearly, let us say for your understanding purpose, okay, what it may be. Now if you see here, when I say this is what your input voltage, when input is positive, if you start with positive, this is what is the case. This is off, this is on. Then your capacitor is charging instantaneously. Then your capacitor is also tracking your input. Your capacitor is tracking your input. Once it reaches peak value, therefore let us say this is what is your 5 volt. Let us say this is what is 10 volt peak to peak sine wave is applied. This is 5 volt and this is what is our minus 5 volt, right? Once it reaches, now we are plotting your output voltage V0, not V0. Let us say I am planning to plot V2 minus V1, therefore V21, let us say, which is positive, right? Therefore this is what is charging, then it is charging, your capacitor is charging to plus 5. Let us say once it reaches plus 5 volt, this is what is your 5 volt. Once it reaches to 5 volt, right? Now your input starts decreasing, less than 5. When this is what is less than 5 volt, when this is what is less than 5 volt, right? For the negative half cycle, this is 5, this is less than 5. Then your diode D2 is off. When diode D2 is off, this is off, still this is positive, this is off, then everything is off, off. Your capacitor is holding 5 volt. Your capacitor is holding till what point? Till this point. Your capacitor is holding 5 volt. I am speaking with respect to first cycle, right? First cycle. Now, when VA is negative, right? Then already your capacitor V2 is charged to 5 now, right? Already it is charged to 5 now. Now when VA is negative, this is what is conducting. Let us say initially this is what is 0 because we are in the starting cycle. Then when this is 0 and this is negative, therefore this is on, then your VI, your capacitor C1 is tracking to negative voltage. Then when that is what is tracking to negative voltage, but your still V2 is 5. Then when this is tracking 0, minus 1, minus 2, minus 3, minus 4, then 5, minus 1, 5, minus 2, 5, minus of minus 3, this voltage is also increasing. Therefore maximum it will go to what? It will go to minus 5 volt. And this is what is going to minus 5 volt. Then 5 minus of minus 5, it will be 10. Therefore how it is going? In the same way, you can say the sine wave, how the sine wave is going like this, it will be also going and it will stay there. Now where did you go? 5. Now this is what is 5 volt. Now actually this is nothing but 5 volt minus of minus 5 volt, which is nothing but 10 volt. It will stay there. Therefore now tell me, this is what is 5, this is what is minus 5. Now again when the negative voltage is decreasing, this is minus 5, this is minus 4, your D1 is also off. When D1 is off, maybe if you ask me here, your D2 is on, here your D2 is on, here D2 is on, D1 is off only, your D1 is off, but here your D2 both are off, but here when it is tracking, your D1 is on, your D2 is off, but again here, right, whatever you have, both off but handling 10 volts. Now again this is 0, again it is charging. When this is what is charging, Nothing, right? This is 5 volt. Whatever voltage you have, maximum it can go to plus 5, minus 5. Therefore, your diodes won't be conducting at all. Then always you'll have 10 volts at the output. Always you'll have, this is what is for the first cycle. Therefore, whatever I told at time t is equal 0, whatever you are starting, positive half cycle and the negative half cycle, this is what is the case. But once the capacitor is charged and then stored, now your VI maximum is going to 5. If it is more than 5, then only it will be conducting. Then only it will be charged more than 5. But your input is always sine wave, which is what is plus 5 minus 5. Then always it will be holding. Then if you ask V2 minus V1, you will get plus 10, or V1 minus V2, you will get minus 10. That depends on that. Therefore, always it will have plus 5, then it will be having minus 5. Okay. Here it is always, that's what, it is less than or equal to 5 volt, and it is also more than or equal to what? Minus 5 volt. Greater than or equal to minus 5 volt. This is what is under steady state. Then this is what you get. Therefore, what is the answer? It is doubled, right? Whatever peak you have, plus 5 minus 5. Now the peak, whatever you are getting is double, 2 times you are getting, right? The positive peak, negative peak. The negative peak is added to positive peak, and that is what is maintained, which is what is 10 volts. Therefore, what is the answer? Answer is D, voltage doubler. Answer is D, voltage doubler. Write down. Okay. See, this is what is the starting cycles, starting half cycle. If you consider positive half cycle, that is time t is equal to 0. If you consider negative half cycle, that is again time t is equal to 0. But if you consider from the first next cycle onwards, it is always 10 volts. Should be very careful. Okay, wherever there is a diode and capacitor, it's not typical clamping circuit. Some 2 diodes and then 2 capacitors. Okay, then your capacitor will be tracking to what you call. It is like going to twice. Number 4, you can follow me. For the circuit shown in figure below, assume that the GNR voltage diode is ideal, okay, with a breakdown voltage of 6, the waveform observed across R. It is straightforward. This is 12 sine omega t, whatever it may be, and this is what your GNR diode. It's not regulator. Okay, it's diode problem. This is R and this is what is VR. This is what is 6 volt. Okay, this is, you can call it as this is VI. Then asking for what is VR, waveform. Okay, option A, option B, option D. Now if you see here, don't write anything, don't respond to this. This is a diode problem. It's not regulator problem, diode problem. Don't respond to this. You treat this as PI. Okay. Now tell me when will be your, for the positive values of this is plus, this is minus. Okay. Maybe for your understanding, open the diode. Actually I can do directly, but if you want to understand, to find the status, when you open, right, and this is what is your VI, this is what is your VI, don't respond to actual input, okay, and this is what is your VR, and bring back your diode. Therefore now tell me, there is no current, then whatever VI we have here, the same voltage will come here, right? Therefore whatever we have, let us say this is plus, minus, and this is what is plus, minus. That is what is voltage. Therefore when VI is positive, then your GNR diode is in reverse bias, right? Until what? Until it crosses the breakdown voltage, because it is in reverse bias, right? When VI is negative, then this will be minus and then plus. If this is what is minus and plus, if this is minus and this is plus, and this will be minus and this is what is plus, then P is connected to, this is what your P, and this is what your N, right? This is your P, and this is what your N. P is connected to positive and is connected to negative, right? Then when VI is negative, your GNR diode will be on. Therefore, case A, let us say your VI is less than 0, then your GNR diode is on. When GNR diode is on, it is simply ideal, right? Forward bias only, right? And this is what your resistor, and this is what your VI, right? Then this is what your VR. Therefore, tell me what your VR. Your VR is equal to VI. Both are in parallel. Case 2. When VI is greater than 0 volt. When VI is greater than 0 volt, that is what is positive. Then your GNR diode is in reverse bias. But remember, case A, it is 0 less than VI less than until what? Until it enters into breakdown, which is 6 volt. Therefore, if this is what is the case, your GNR diode is in reverse bias, which is nothing but off. That is nothing but reverse bias. And this is what is forward bias. When this is in reverse bias, it is open. And this is what your VI. And this is what your VR. Your VR is 0 volt. Now case 3, you can follow me, okay? Case 3, now, sorry, not case 3, case B, when VI is greater than or equal to 6 volt. When VI is greater than or equal to 6 volt, when VI is greater than or equal to 6 volt, plus minus, then it will be entering into breakdown. Your GNR diode is in breakdown. Then what is the circuit? Your circuit will be, this will be a battery of 6 volt. And this is what your VI, and this is your R, this is what your VR. Then apply KVL. Let us say this is plus minus, then minus VI plus 6 plus VR is equal to 0, and your VR is equal to VI minus 6. This is what. Then if you write now the transfer curve, this is what your VI and this is your VR. The break point is what? The break point is less than 0. Then if it is less than 0, this is 0, and another break point is 6 volt. This is what is 6 volt. If VI is less than 0, then output is same as input. When VI is in between 0 to E, that is off. More than this, this is what. Therefore, this is nothing but your V0 is equal to VI. Here V0 is equal to VI minus 6, and here V0 is equal to 0 volt. This is what it is. Once you know this, if you have a sine wave is given with peak to peak, right? 24 volt peak to peak. This is what is the sine wave for all the problems, same thing. This is what your 12 volt, and this is what is our minus 12 volt. That is what is given. Now tell me, you want to plot output voltage. When you want to plot output voltage, tell me 0 to 6. Actually, this is what is your 0 to 6, right? Till this point, tell me if your input is in between 0 to 6. In between 0 to 6, your output is 0 basically. This is 0, this is 0. Okay? Then, what is if input is negative? Same as your output. Therefore, this is what it is. And when input is more than 6, it follows, then it will go to what? It will be having maximum. When VI is equal to 12, then 12 minus 6, it will be 6. Therefore, it will be touching it. Therefore, this is 6 and this is what is minus 12 volt, and this will go to 6 volt. Therefore, this is what is your output. Which is what is satisfying that? Option B. Therefore, answer B. Answer B. Take it. Same procedure. Blind procedure, if you follow, you'll get the answer. This is linked answer problem. What is the linked answer problem? If first bit is correct, then only second bit will be evaluated. Five and 6. Data is given. In the circuit shown below, assume that voltage drop across each diode 0.7, that is what is given, and VT, which is nothing but KT by Q, which is 25 millivolt, and VI, small signal input voltage VI, is equal to Vp cos omega t, where Vp is nothing but 100 millivolt. Vp cos omega t, where Vp is 100 millivolt. This is what your common data. And circuit is given. Okay, circuit is four diodes are in series. This is what your small Vi, which is given here, and this is 12.7 volt, and this is 9900 ohm. Now actually saying that it is having plus VDC plus VAC. Similarly, it's having IDC plus IAC. What is the seventh bit? If this is the problem, the seventh bit is what is IDC, right? Only DC current. Then what is eighth bit? What is VAC? What is AC output voltage? Okay, it is straightforward. If you observe clearly, the first bit is related to DC analysis. Means when I speak about DC analysis, I don't bother about AC signals. Okay, therefore this is related to DC analysis. When I say DC analysis, what is our DC circuit? If you take DC circuit, what is DC circuit? All AC components are not there. Only biasing circuit, means is asking IDC, not IAC. Actually this IDC is because of your VDC. Your IAC is because of your small signal voltage what you have here, right? Therefore, if you want to find only bias current, right, then no need to apply VI only because of that. What is the case? Then this is nothing but plus minus 12.7. Then it is a resistor and a PN junction diode. There are 4 PN junction diodes. Everything is having only VDC. This is what your VDC. Okay. Therefore, now this is what is 9900 ohm, and we want to find IDC. Okay. Now, strictly speaking, therefore, what is our PN junction diode? Your PN junction diode should be represented with what? V gamma, which is 0.7, and then on resistance. That on resistance will be very small, that you can ignore with respect to 9900. You can ignore. Then let me calculate IDC. IDC is nothing but only if I say 0.7, 0.7. Let us say this is having 0.7, 0.7, and this is also 0.7, and 0.7, and 0.7. Then tell me, out of 12.7, 1, 2, 3, 4, 4 into 0.7, 2.8 divided by 9900. How much is this? This is nothing but 9.9 divided by 9.9 K, which is 1 milliampere. Therefore, what is your IDC? Your IDC, your bias current is nothing but 1 milliampere. What is the answer? Problem number 5, not 7. What is the answer? Problem number 5. Answer is A, 1 milliampere. Your answer is A. Answer is A. Now let's see second bit, which is sixth one, asking for VAC. Therefore, only AC analysis. Therefore, AC analysis. Can you consider AC analysis? Right? Only AC circuit. What is AC circuit? Don't bother about DC quantities. Don't bother about 12.7. Therefore, only AC signal. This is what is your VI. The dynamic resistance of your resistance is about 9.9 K only. Let me call this as 9.9 K. And now each diode is represented with the forward resistance This is RF, 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 and now this is what is our VAC, right? Therefore, this is nothing but what is VAC? Your VAC is equal to 4 into RF potential divider network is equal to 4 into RF plus 9.9K into your input voltage what you have. Okay, if you find RF, problem is over. To find RF, we know that what is RF, I already told. What is dynamic resistance? Eta Vt divided by I. Now eta, if nothing is given, you can take eta is equal to 1 Vt, that is given 25 millivolt. I, what is I? The DC bias current. Therefore, your dynamic resistance is depending on your DC bias current, whatever we solved in problem number 5. Therefore, this is what is nothing but linked answer problem. To solve the second bit, you need first bit answer. If first bit answer is wrong, surely your second bit answer is wrong. That's why second bit won't be evaluated if first bit is wrong. Let us say I is equal to 1 milliampere, eta is equal to 1, then Vt is 25 milli. Therefore, 25 millivolt divided by 1 milliampere. Therefore, what is your RF? RF is nothing but 25 ohm. Therefore, what is your VAC? Your VAC is equal to 4 into RF, 100 divided by 4 into 100 plus 9.9K, which is 10K into your VI. Then it is nothing but K will become milli, 10 milli into your VI. What is VI? VI is nothing but 100 milli. 100 milli into 10 milli, 1000 milli. 1000 milli is nothing but 1. Therefore, it is simply nothing but cos omega t. This is what is your VAC. Therefore, what is your output? Your output is B. Your output is B. Answer is B. Something is wrong. 10 milli into 100 milli, 1000 milli. No, 1000 milli square. Therefore, it is into milli because it will not do amplification. Remember, into millivolt. Okay, fine. That's what is correct. I think problem number 5 and 6 they are over. In the figure, assume that the forward voltage drop of PN junction diode D1 and Schottky diode D2, Schottky diode D2 are 0.7 and 0.3. Therefore, V gamma of PN junction is 0.7 volt and V gamma of Schottky diode, right? Is 0.3 volt. If on denotes conducting the state of the diode, off denotes non-conducting state of the diode, then the circuit. Okay. Yeah, this is important. Actually, this is also important problem. You will understand. This is Schottky. Schottky diode is nothing but it's P and N. It is one is metal and other is S. Okay, not Z. Metal and semiconductor. Its cut-in voltage is different, but you think like when you solve the problem, you think like it is a PN junction diode having cut-in voltage of 0.3. You just think in that way. This is D2, D1. Here it is both the semiconductors P and N, PN junction. One is semiconductor, another is metal. That is what your Schottky diode, metal semiconductor diode, which is having lesser V gamma, right? That you will get when you have metal wire is connecting to a semiconductor in the fabrication. That is a MOSFET drain and source will be connected to external wires, right? Then that wire and then semiconductor will have a Schottky diode action. Okay, that's fine. That is having V gamma 0.3. Now asking for the status of diodes D1 and D2. And what is the voltage? The input voltage is 10 volts. Okay. Now only the problem is understanding the diode status. Okay. We don't need the status of diode, right? What is the technique? Open the diodes. Open the diodes. When you open the diodes D1 and D2 to find status. To find status. That is the problem. To find status. When you open, this is very important, you have to observe. Now this is your 1K opened and this is also opened. This is your 10 volts and this is 1K and this is 20 ohm, and bring back your diode. This is D1 and bring back your diode, your Schottky diode. Okay, this is D1 and D2. This is your D1 and D2. When you open, is there any current which is flowing through the circuit? 1 ohm, sorry, is it 1 kilo ohm? Yeah, 1 kilo ohm and then 20 ohm. Okay, if this is the case, therefore now tell me, the current which is what is flowing? Nothing. Current, the voltage drop is 0, voltage drop is 0, whatever 10 volt you have, that you will see here, therefore here it is 10 volt, let us say 0, reference, the same 10 is coming here, and then reference. Tell me, under open circuit condition, because we have two diodes, right, this is off, this is also off, sorry, open, then open terminal voltage 10, out of 10, whatever it needs, it will take and then remaining voltage will be given to the resistors what you have, right. Now D1 will be conducting, D2 is also conducting according to this. Therefore, let us say case 1, this is very important. If you say that according to this, D1 and D2 are on, then what you get? Therefore, this is what it is. This is 1 kilo ohm, right? Then when this is what is on, which is nothing but 0.7, this is what your 0.7, and this is what your 20 ohm, and if you say this is what your 0.3, after when I say both are on, it will take that much and the remaining voltage will be given to this. This is what is 10 volt, right? Now if you see here, when I say this is what your 0.7, right, out of 0.7, this is 0.3 taken, remaining 0.4 should be going here. When I say remaining 0.4 is going here, 0.4 volt divided by 20, that much current should flow from what? That should come from here. 0.4 ampere is coming means, which is what is 400 volt. This is not serving the problem. Actually, maybe if you observe clearly, what is this? This is what your current I. Let us say this is I1 and this is I2. Tell me what is your I2? Your I2 is nothing but the current which is flowing through 20 ohm is nothing but this voltage 0.7 minus 0.3 divided by 20, which is nothing but 0.7 minus 0.3. Let us say 400 milli divided by 20. 0 will be cancelled, which is nothing but 20 milliampere. Right? Then what is your I1? We don't know, but definitely I is greater than 20 milliampere. Therefore, your I is greater than 20 milliampere. If I is greater than 20 milliampere, what is voltage across 1 kilo ohm? Voltage across 1 kilo ohm is 20 milli into 1k. 20 milli into 1k, which is nothing but 20 volt. From where you get 20 volt? It is not satisfying KVL. Therefore, this is 10 out of 10. If you say 0.7, 9.3. Therefore, KVL and KCL are violated. Therefore, something is wrong. Therefore, this is not expected. Something is wrong. Then what is that something wrong? Surely both will be not be on. Okay? Remember, let's see. Let us say case 2. Because it needs only 0.3, maybe the moment it is having 0.3, this loop is established. Then let's see what is the voltage here. Therefore now see wherever you have combinations, right? Two diodes, 3 diodes, 4 diodes. Remember, with respect to this, you cannot say that both are on. If both are on, something is violated. Therefore, that is not correct. Then what we need to do is, yes, let us say first D2 on. Then see the status of D1. If this is on, fine. But definitely that will not happen. Let us say when D2 is on, if D1 is off, fine. Let us say D1 is on, if D2 is off, then we need to do the cross combination. Because if you say according to open terminals, if you say both are on, then it is violating your KVL or KCL. Therefore, this is wrong. Therefore, let us start with when what? When D2 is on. Let us say let D2 is on and D1 is off. Okay, you take this condition and then try to calculate whether KCL, KVL they are satisfied or not. Then we will see correct. Almost the time is over for this session. You can take, we have 1 minute time. You try to take this and then try to solve for this. When D2 is on, D1 is off, what are the conditions? Then let's see KCL, KVL satisfied, then that will be the solution. If that is also not satisfied, we need to see D1 on, D2 off. All cross combinations we need to see which one is satisfying KCL, KVL, that is the correct answer. Okay. I will continue in the next session. In the meantime, you try to solve. Okay. Thank you.